All right, so whenever you're dealing with collisions, you should always be thinking about conservation of momentum. That is something that will always be true in any collision. And this is one of the major frameworks that you can use to solve a lot of mechanics problems on the MCAT. But sometimes it can be tricky because collisions don't always look like the most obvious type of collision that you're used to encountering. Sometimes a collision will involve one object breaking into two objects. For example, if you have a large radioactive nucleus that breaks into an alpha particle that shoots in one direction, and the remaining part of that nucleus recoils in the other direction. That is a collision because whenever you see objects that combine or break apart, that's an example of an inelastic collision, and that's something to always be mindful of when you're working through your physics problems and curious about whether or not to tackle that as a collision. Now, there are two types of collisions. One is an elastic collision and the other is inelastic. Elastic simply means that the objects bounce off of each other and head in different directions without any work or heat being involved in this. There's no malformation of the objects, there's no heat being released, and because of that, you conserve both kinetic energy and momentum. So if you have an elastic collision, kinetic energy is being conserved. So the 1/2 mv squared formulas will all add up, and that will be conserved in that collision. Inelastic collisions might involve cars crashing because work is done on the shape of the car. There's some malformation of the vehicle. Whenever you have two things that stick together, that's another example of an inelastic collision. Or if you have things break apart, that's a third type of inelastic collision that you can be dealing with. Whenever you have an inelastic collision, that can only be solved using conservation of momentum because the energy will be lost as heat or work. So the kinetic energy will not be conserved in that case. The kinetic energy will be converted into a different type of energy, and so just using kinetic energy won't be enough to solve that problem. Now, some things to be mindful of when you're working with collisions is first that the momentum is conserved in the vertical and horizontal directions. So if you have unusual angles, resolve those angles into horizontal and vertical components or left and right components and things like that. Recognize that whenever you're dealing with an inelastic collision, that can involve objects combining or breaking apart, but it doesn't necessarily have to be that way. Objects can bounce off each other, but if the objects are malformed or deformed in some way in that collision, then that's still inelastic, but the objects don't have to stick together in that case. And remember that you have to resolve those angles, as we mentioned earlier. And remember that the momentum formula is P equals mv. And so if objects do combine, you have to consider the new momentum, the new mass when you're considering this new momentum. And so the objects will have a new mass, but the overall momentum will still be conserved, and you can consider the direction of the momentum because it might involve there was initially no momentum, but now there is momentum in both directions. Remember that mass plays a role and direction also plays a role. And with that, you're ready to encounter collisions.